If every motion in the universe stopped for just 1 second, gravity wouldn't be the thing that kills you. The stopping would. Earth's surface at the equator is already moving at roughly 1,670 kilometers per hour. If that motion ended instantly, the planet would stop. You wouldn't. Everything not anchored to the ground would continue forward at full speed. And Earth isn't even unusual. Somewhere in our galaxy, the crushed core of an exploded star spins 716 times every second, its surface racing at nearly a quarter of the speed of light. Which raises a much stranger question. Why does almost nothing in the universe ever stop spinning? Start with the easiest assumption. Maybe extreme spin only belongs to extreme objects, crushed cores and collapsed stars, things already broken apart by violence. Your own planet proves that assumption wrong immediately. It is nothing like a shattered star, and it has been turning non-stop since before life existed here. No damage caused it. No explosion started it. It arrived already spinning, and nothing since has been strong enough to stop it. Which raises an odd problem. If nothing out there is strong enough to stop it, why do scientists still say Earth's rotation is slowing down? Because it is, barely, and the reason is not friction with empty space. The moon's pull drags against our oceans, and that drag steals a sliver of spin from Earth every single day, so little that a day only lengthens by about 2 milliseconds per century. But that theft has been happening for billions of years, and early in Earth's history, a single day lasted roughly 6 hours, not 24. Motion is leaving Earth every single day, and it has to be arriving somewhere. Follow it, and it leads somewhere much closer than you'd expect. That stolen spin does not disappear. It moves into the moon, pushing it slightly farther from Earth every year, about 3.8 centimeters, close to the speed your fingernails grow. And that same slow exchange is why the moon shows you only one face forever. It stopped fighting Earth's pull a long time ago and now turns in perfect step with its orbit. Pluto and its largest moon, Charon, show what happens when that exchange finally finishes. They are locked to each other on both sides at once. Pluto always shows Charon the same face, and Charon always shows Pluto the same face back. Stand on the correct side of either world, and the other one hangs motionless in the sky forever, never rising, never setting, never moving at all. That is what spin looks like once two small nearby worlds finish trading it back and forth. But Pluto and Charon are both lightweight and both close enough to grab hold of each other. What happens to something enormous with nothing nearby large enough to lock onto at all? The Sun has no partner close enough to drag against, and yet it refuses to rotate as a single, orderly object at all. Its equator finishes a full lap in about 25 days. Regions near its poles take closer to 35. For anything solid, that difference should be impossible. Different parts of the same object moving at different speeds should tear it apart from the inside. Imagine a merry-go-round where the outer horses lap the center pole faster than the horses standing right next to it. The whole structure would twist itself apart within seconds. But the Sun is not solid. It is a ball of plasma with no rigid shape holding it together. So it simply ignores a rule that would rip a solid world apart, and has kept ignoring it for over 4.5 billion years. One region of its own surface, constantly outrunning another without ever tearing the star in two. If one star can hold together while spinning unevenly across its own surface, the next question almost writes itself. What happens when you scale that same problem up to 100 billion stars, all orbiting together, with nothing solid connecting any of them at all? Galaxies rotate too, and they rotate in a way that should not be physically possible. Every star inside a galaxy is held in its orbit by the gravity of everything around it. So stars near the crowded center should move noticeably faster than stars drifting near the sparse outer edge. Measure the actual speeds, and that difference barely shows up. Outer stars move almost as fast as inner ones, as if some enormous amount of extra mass was spread through the galaxy that no telescope has ever managed to see. Astronomers gave that missing mass a name, dark matter, and decades later still cannot say exactly what it is. All anyone knows for certain is that without it, a spinning galaxy should be flying apart, its outer stars slung off into deep space the moment the visible matter alone stopped being enough to hold them in. Picture a carousel spinning fast enough that the horses near the edge should be thrown clear off their poles, except somehow they never are, held in place by something you cannot see, cannot touch, and cannot detect with any instrument pointed directly at it. That is essentially what every large galaxy is doing right now, including the one you are sitting inside. So an invisible mass is quietly holding entire galaxies together as they spin. But at the very center of that same galaxy, spin stops being something gravity merely fights against and starts being something powerful enough to fight back. Most large galaxies, including our own, hold a supermassive black hole at their core, some rotating close to the fastest rate physics allows. A black hole spinning that fast does not just sit there and turn. It drags space itself around with it, an effect physicists call frame dragging. Get close enough to a black hole spinning at that speed, and no engine, however powerful, could hold you still, because the space you are trying to stay still in is itself being swept forward, a whirlpool built out of the fabric of the universe instead of water. That effect has been measured indirectly through the way light and orbiting matter bend and shift near real black holes. At this scale, spin has stopped being just a property something has. It is powerful enough to grab hold of space itself and force it to move, the single most extreme thing rotation is known to do anywhere in the universe. Which leaves one question none of this has actually answered yet. If spin can warp the fabric of reality by the time it reaches a black hole, where did that very first trace of it come from in the first place? Trace it back far enough, and every rotating object, your planet included, started as a loose, drifting cloud of gas and dust in space. For that cloud to collapse into something with zero rotation, every particle inside it would need to fall in a perfectly straight line toward the center, with no sideways motion anywhere at all. That kind of perfection has never once been observed. Even a cloud that looks smooth from a distance carries microscopic differences in density, a fraction more matter here, a fraction less there. At the smallest scales, this near-perfect evenness becomes even less likely, since perfectly symmetric starting conditions are extraordinarily unlikely to ever occur in nature. Some imbalance is almost always present. Under normal conditions, that imbalance would mean nothing. But the cloud is not staying the same size. Gravity pulls it inward, and as it shrinks, that faint imbalance has nowhere to go. It concentrates. The same physics that lets a figure skater spin faster by pulling their arms in takes hold of the entire cloud. Except this is happening across a distance measured in trillions of kilometers. Picture a crowd of people scattered loosely across a stadium, each one drifting a little differently and then slowly forcing that entire crowd toward a single point at the center. Their small, uncoordinated movements would not cancel each other out. They would collide, merge, and start circling the center together, because there is nowhere left for that motion to go except around. An undetectable drift becomes a measurable spin. That answers where it begins, but it leaves the harder question untouched. Once that spin exists, what stops it from simply running down the same way everything else eventually does? The answer is not luck. It is one of the most rigidly enforced rules in the entire universe. Physicists call it conservation of angular momentum, and it sits in the same category of law as the conservation of energy. Once a system has a certain amount of spin, that amount cannot simply shrink or vanish on its own. It can only move from one part of a system to another, the way Earth quietly hands a portion of its own spin to the Moon every year, or transform into a different kind of motion entirely. It never needs a constant push to keep going. It only stops if something external actively grabs hold of it and takes it away. That is why a spinning top slows down, because friction with the table and the air is actively stealing its momentum, and why the same top would keep spinning for a very long time on a perfectly frictionless surface. Space is about as close to that frictionless surface as anything can get. There is nothing solid to grip, nothing to push back, nothing to quietly absorb the motion the way a tabletop does. So the spin a planet, a star, or a galaxy is born with is not a temporary condition waiting to fade. It is closer to a debt the universe is legally required to keep paying for as long as nothing steps in to collect it. So if you ever come across something in this universe that has actually permanently stopped turning, do not relax. That is not peace. That is what running out of everything looks like. Rotation itself does not need to be fed to keep going. Once an object is spinning and nothing external grabs hold of that motion, it simply keeps turning indefinitely without asking anything of the universe around it. But there is a difference between motion continuing and motion being able to do anything. At the far end of time, after every star has burned out and every collapsed core has gone dark, the universe reaches a state physicists call heat death. Particles still drift, light still travels, nothing technically stops moving. What disappears is the difference, the usable energy that lets anything organize, transfer force, or change at all. An object can go on spinning through that state. It just stops being able to matter to anything else, which means stillness was never the natural condition of anything. It is not what things return to when left alone. It is closer to the last thing that happens, the signature left behind once a system has completely run out of usable energy to move anything at all. You are not spinning by accident, and you are not spinning because some force keeps pushing you. You are spinning because nothing has ever come along strong enough to take that motion away. And in the emptiness surrounding almost everything in this universe, nothing ever does. Somewhere out there, an object born from the same faint imbalance as everything else is still turning fast enough to tear apart anything that gets close, still obeying the same law your own planet has been obeying since before there was anyone here to notice it.